everybody, this is Mrs. Dunn. What I wanted to show you in this video is how to estimate a population proportion. So what we're going to be covering is what I'm going to do is I'm going to start with an example, and through that example, first we're going to define P and P hat. We're going to find critical values. We're going to find E, the margin of error for proportions. And we're going to construct a confidence interval. After we've constructed the confidence interval for a population proportion, I want to talk to you about how to interpret that interval. And now, once we've done all this, then what we're going to do is I'm going to show you how to, on your calculator, construct the confidence interval. Okay, so let's get started. Let me show you an example. So this example was taken from your book. It has to do with medical malpractice. So let's read this. In a study of 1,228 randomly selected medical malpractice lawsuits, it was found that 856 of them were dropped or dismissed. What we're asked to do is to construct a 95% confidence interval for the proportion of medical malpractice lawsuits that are dropped or dismissed. So what's the difference between P and P hat? Let's take a minute and talk about that. So P is the true proportion of medical malpractice lawsuits that are dropped or dismissed. If you took every medical malpractice lawsuit in the country, every single one of them, and counted how many of those lawsuits were dropped, that fraction of the number dropped over the total number from the whole entire country, that value right there is the true population proportion. We don't know that because we don't have every single medical malpractice lawsuit. We have a sample of them. So P hat represents the point estimate. P hat, the best way to explain that is our best guess at what P actually is. P hat is the point estimate, the best guess. So let's look at what that would be for this problem. So in this problem, we have 1,228 malpractice lawsuits, and 856 of them have been dropped or dismissed. So our P hat in this example is 0.697. That's our best guess. Our best guess is approximately 70% of all medical malpractice lawsuits are dropped. Okay, what we want to do is we want to construct a confidence interval for what that actual proportion is. We don't know what it is. We just have a guess. So we want to construct an interval, and we want to be 95% sure. That's what this 95% means, that our actual value of P is going to be in that interval. To do that, we have to know what our critical value is. Remember, we're constructing a 95% confidence interval. I believe that your book does a really nice job of explaining how we're going to find that critical value or the critical values. So we want a confidence level of 95%. So that means that the area in the shaded region is 0.95. So 95% of the total area is in this shaded area of yellow. So that means 5% is in the left tail and the right tail. This is the right tail, this is the left tail. And so those shaded green regions have to add up to 5%. Think about it. 95 plus 5 is going to add up to 100. That's the whole thing. So 0.95 is in this yellow area, and 0.025 is in each of these green sections. So to find this critical value right here, we are going to type that in our calculator. So we're going to go to the inverse norm function on your calculator. You can follow along with me. And you'll see I've already submitted that the area to the left of the z-score we're finding is 0.975. Why 0.975? Why not 0.95? Well, the reason why it's 0.975 is because it's this total area 0.95 plus 0.025, this area in the left tail. And so we want the z-score where the area to the left of it is 0.975. And you'll see that value is 1.96. That's shown right here, but I wanted to show you how to find that on your calculator. So you're going to have to use the inverse norm function if the value, or I'm sorry, the confidence level you're looking for isn't 90, 95, or 99. Your book has a nice chart for the confidence levels, the critical values for the confidence levels of 90, 95, and 99. And it writes them in this chart because they're the ones that are used the most often. But now you have the tools, you know how to find it on your calculator. Okay, so our critical value is 1.96 because we're doing a 95% confidence interval. All right, that's the critical value. Next step is to find E, the margin of error. Here's the formula for the margin of error. So we need the critical value, we need P hat and Q hat, and we need the sample size. So all of that information we have. P hat, our point estimate, our best guess, is 0.697. So Q hat, if you remember from previous chapters, Q is going to be 1 minus P. It's the same thing with P hat and Q hat. If P hat is 0.697, Q hat is 1 minus 0.697, the complement. You remember that from before. So when we plug those numbers into our calculator, if we plug those numbers into the formula, it's 1.96 times the square root of 0.697 times 0.303 divided by 1,228. N is 1,228. These numbers should always add up to 1. So when you type that in your calculator, you'll get an error of 0.026. It comes out to like 0.025 something, and when you round it, it's 0.026. Okay, so now we have E, the margin of error. We have our point estimate, and that's all we need to construct our confidence interval. So the confidence interval is that our value of P, which is, remember, our true proportion, is going to be between P hat plus or minus E. So P hat is 0.697, E is 0.026. So 0.697 minus 0.026 and 0.697 plus 0.026. And so our confidence interval is that the true proportion is going to be between 0.671 and 0.723. We are 95% sure it's going to be between those two numbers. Okay, so let me explain that again. This is the confidence interval and the math behind how we found it. But now let's talk about how I just interpreted that, and I've written it down here. So we have 95% confidence that the interval from 0.671 to 0.723 actually does contain the true value of the population of medical malpractice lawsuits that are dropped or dismissed. Okay, we don't know what the true proportion is, and we could be off, but we are 95% sure that it's going to be between those two values. All right, how do we do that on our calculator? So let me clear this for now. Let me show you how to do it on our calculator. So what you want to do is you want to find this function, 1 proportion z interval. That's found under the stat menu. So you're going to press stat and tests and toggle down to 1 proportion z interval. And what you're going to put in here is the information we were given in the example that we're going through. X is the number of lawsuits that were dropped or dismissed, which was 856. 1228 is N, or the number of malpractice lawsuits that were covered, 1,228. The confidence level is 95%. We'll change that to a decimal 0.95. And press calculate, and you'll notice that we got the same interval. It goes from 0.7671 to 0.723. And that's how you do it on your calculator. All right, good luck, everybody. Please email me if you have any questions.